Let's take a look at the idea of marginals. For example, marginal revenue represents the rate of change of revenue, and in general a marginal represents rate of change. If I have a revenue function that represents the amount of revenue when X units are sold, the derivative, which represents the rate of change of that function, the derivative can be thought of as the marginal revenue. So the way this works, we can kind of think of marginals as approximating the amount of the next unit, the amount of the next unit sold, in the following sense. In the diagram here, the black curve is our revenue curve, and at any particular point, say at a point X, the tangent line to that curve is going to be really close to the curve, at least for a little while. And so 1 unit away, the difference between the actual change in the curve, the difference here between the actual change in the height of the curve and the slope of the tangent line, 1 unit away, the change in the height of the tangent line is going to equal the slope. Those differences are quite similar. And so we can use the slope value, which if we move 1 unit to the right, the slope is going to be equal to the change in height. We can use that slope value to approximate the change in height of the curve. And so in that sense, we're thinking of marginal revenue as representing the approximate amount that the revenue function will change by if we increase sales by 1 unit. In a similar way, we can talk about cost functions and marginal cost, and we can talk about profit and marginal profit. So let's look at an example. Suppose the revenue from selling X washing machines is given by this function, R of X equals 30,000 times 1 minus 1 over X, and the value of the function is in dollars. We want to find the marginal revenue when 100 washing machines are produced. So marginal revenue is the derivative of the revenue function. It describes the rate of change of the revenue function. So I want to take the derivative of 30,000 times 1 minus 1 over X. Using the constant multiplier rule, since 30,000 is just a constant that's multiplied by this other stuff, I can bring the 30,000 to the front and focus on taking the derivative of 1 minus 1 over X. 1 over X isn't a very nice form though. So let's rewrite this once more as 30,000 and 1 over X, I can write that with a negative exponent. It's the same as X to the negative first power. And so now the power rule, I can apply kind of simple rules to both of these. The 1 is simply constant. It's a constant term, and so it goes away. It becomes 0, and the X to the negative 1, well, the derivative of that is going to be negative from the minus sign, and then negative 1 times X to the negative 2, because I want to subtract 1 from the negative 1. And so we can rearrange this a little bit, make it a slightly nicer form. If we make this a positive exponent, and if we cancel out these two minus signs, we end up with 30,000 over X squared. So that's our revenue function, and I want to figure out the value of that when X equals 100. So if I plug 100 into that, we get 30,000 over 100 squared, but 100 squared is simply 10,000, so this turns out to just be 3. With an applied situation like this, it's important to think about what the units of a number like that should be. What are the units of 3? Well, we're talking about the derivative of R with respect to X, and the R units are dollars. The revenue amount is in terms of dollars, and X is in terms of the number of washing machines. So this 3, following the pattern that we've seen, it's dollars per washing machine. So what that means is that we would expect the revenue to increase $3 for each additional washing machine that is sold. And so we can use the idea of marginal revenue to estimate increases in revenue that will result from increasing production from 100 machines to 101 machines per week. So in addition to the fact that R prime of 100 equals 3, I also want to know what the original expression is at 100. So if I plug 100 into that, I can think of this as 30,000. 30,000 times 1 minus 30,000 divided by 100, distributing the 30,000. 30,000 divided by 100 is simply 300, so we end up with 29,700. And the units here is in dollars. The units are dollars. Here we have dollars per washing machines. So it turns out one perspective, and a pretty useful perspective for marginal things like marginal revenue, is we can consider the marginal revenue function to be an approximation of the change in function value from x to x plus 1. So we can think of it as the difference between r of x plus 1 and r of x. And this relates to the way that the derivative comes from the difference quotient. If you think of the difference quotient and make h equal to 1, we would end up with this expression. And so rearranging this a little bit, if I add r of x to the other side, I end up with r of x plus r prime of x as being approximately equal to, squiggly equal signs, r of x plus 1. So we know r of x and we know r prime of x for 100, and we just figured out what those numbers are. And so the approximation, the estimation that we're trying to make here is for r of 100 plus 1, we're figuring out the revenue value for 101. I can think of that as 100 plus 1. And so that's this side. And that's going to be approximately equal to the revenue at 100 plus the marginal revenue, which represents like the revenue from one more unit. And so we get 29,700 plus 3. And so marginal revenue is approximately equal to $29,703. So if you want to think about this for a moment, there is kind of an issue with the units. We're taking a dollar amount and a dollar per washing machine amount. We can resolve that difference by thinking about what this number 1 represents. This number 1 represents a change in x, and so it is also in washing machines. And so if I multiply that to the other side, there's actually kind of a sneaky little like 1 here that would make the units work out. So this is actually like dollars per washing machine is what the marginal revenue gives us, dollars per washing machine, but then we're multiplying by the number of washing machines. So we're changing by 1 washing machine. If I wanted to change by 2 washing machines, I could take that 3 and multiply by 2. And so the revenue for 102 would be approximately equal to 29,706. The approximation would be a little worse because we're moving a little bit farther away from the given information, but that would be the idea. If I change that 1 to a 2, it would change that 3 to a 6, and so we would get an approximation for revenue, a little bit farther away, 2 units away from the information we know. Well, I hope you enjoyed the video. Thanks for watching.